The questions I'll be going through from the CST review today are questions that correspond to the released questions 41 through 50. So in this first question, what circumstance might a gas decrease in volume when heated? We look to the answer to find and want to know why is it letter C. Well, the gas is placed under increasing pressure. Why is that significant? Because this little guy, P1V1 over N1T1, shows you the relative relationships of first pressure, volume, moles, and temperature. So if we're looking at temperature, what we're going to see is that for temperature, which is down here, the relationship to N, which is moles, is going to be inverse. This is the inverse relationship. When one goes up, the other goes down. Okay, at the top, when we're looking at the relationship of pressure to volume, when we look at that, that is also an inverse relationship. Anybody who is horizontal, okay, this is horizontal. Horizontal in this formula is going to mean that we have an inverse relationship of those guys. Now, when we look at this a little differently now and see the relationship of anybody on the bottom to anybody at the top, that is the vertical relationship. When the vertical relationship is in action, a number of moles is going to be direct. Number of moles is direct with the pressure. Pressure goes up, moles go up. So they have this kind of direct relationship. When we talk about temperature and volume, here's our volume, here's our temperature. When either one of them goes up, the other goes up. Oops, not A. This is just going up. Okay, whoops. There we go. When one goes up, the other goes up. Now, if we look at any of the guys on the top with any of the guys on the bottom, okay, that could be pressure against moles or pressure against temperature. We have the direct relationship. If we do volume against moles or volume against temperature, we also have direct relationship. When one goes up, the other goes up. This allows us to figure out any of these kind of problems. So let's look at letter C and see why that's the correct answer now. Under what circumstances might a gas decrease in volume when it's heated? So we look at volume, which is sitting here, and the heat, which relates to temperature down here. Okay, the gas is placed under increasing pressure. What does pressure do? Is pressure direct or indirect with temperature? And you can see that because temperature's on the bottom and pressure's on the top, they vary directly. All right, so this little guy and this little guy are directly proportional. So when we decrease the volume goes down, and when we want the thing heated, the volume goes down when it's heated. Volume and temperature are directly related. And to get the pressure, increasing pressure, that will mean that the temperature is going to increase. Okay? So that means it's going to get heated, temperature up, and the volume is going to go up. Okay? Increasing pressure, the volume has to go down, for increasing pressure. And so that means that pressure will go up with the temperature. So, any questions on that? You can see me in class. Now, on the next one, a sample of carbon dioxide is at 20 liters at standard temperature and pressure. So we're starting at 20 liters. And what will be the volume of a sample of argon gas that has the same number of moles? Okay, so let's look at the relationships again. PV, N, and T. So they're saying that has the same number of moles, so we don't need to worry about that guy. And pressure. Okay, pressure's out of the ballpark here. So the number of moles and pressure, but we're twice the absolute temperature. So this guy got multiplied by 2, which means this guy also has to get multiplied by 2. And this temperature, of course, has to be in kelvins. That's the only way this will work. And so it's going to go from 20 times 2 is going to equal 40. And that's why letter A is the correct answer. Let's go on. And here we've got standard temperature and pressure is defined as, and this is strictly a definition. So at standard pressure or standard temperature, it's 0 centigrade or 273 Kelvin. They could have had either one here, 273 Kelvin. And 1 atmosphere. So 0 centigrade, 1 atmosphere, or 273 Kelvin and 1 atmosphere. And there you go. You got the whole thing right there. Let's go on. And that's why letter D is the correct answer. And let's see, did we do 3? Yeah. Okay, 4. And under 4, under which of the following sets of conditions will a 0.5 mole sample of helium occupy a volume of 11.2 liters? Well, this is ideal gas law. PV equals nRT. And we want to get both sides of this to be equal. That'll only happen when we get the right answer. So let's try answer A and plug these numbers in. We have moles at 0.5. R is 0.0821. That's always going to be the same. So R is going to be right there. And temperature, temperature on letter A is 273. Okay, over here on pressure, we have 1 atmosphere. And let's get this. This guy was moles, and this guy is kelvins. 1 atmosphere, and the volume they have is 11.2. If these two guys are equal, we've got it licked. So what we're doing here, we're going to have pressure times volume is going to be these two guys multiplying by each other, and that gives you 11.2. On the right side, the 0.5 times the 0.0821 times 273, work it out, you're going to see that that will also come out to 11.2. And so letter A was our correct answer here because these two sides wind up being equal. And they always have to be equal. You work out the numbers on all the other guys and the two sides will not be equal. Satisfy that curiosity for yourself and you'll find out that I speak the truth. Carry on. Next, what is the equivalent of 423 Kelvin? Well, the definition here for centigrade, to get centigrade to Kelvin, Kelvin is going to, well, let's do centigrade. Degrees centigrade is going to be equal to Kelvin plus 273. So 0 degrees Kelvin will be 273 degrees centigrade. Now, we started out with 423 Kelvin, and Kelvin, if we subtract 270, this 270, subtract this from both sides, okay, that will give us the centigrade degrees, and the centigrade degrees were, let's see, we got kelvins of 273, and we're going to subtract the 270, I'm sorry, this guy is 273, not 270. 273. So Kelvin plus 273 is going to be our centigrade. And we got kelvins at 423. So the centigrade degrees, no, I'm not. So if for any reason I don't get rid of the last minute of this recording, disregard it. I'm the king of backwards, and I had that conversion for centigrade and Kelvin backwards. Degrees centigrade plus 273 is equal to Kelvin. That first line that I've written on the screen now. And as we go down one line, you'll see that we can solve for centigrade by subtracting 273 from the Kelvin degrees. And we're given the degrees Kelvin as 423, and we subtract the 273, that gives us 150, and that leads us to our correct answer. The thing that you want to remember about this question is that at 0 degrees Kelvin, all motion stops. When all motion stops, there is no pressure. No pressure. Because pressure happens when molecules bounce up along or against the inside of a container. So if there's no motion, there's no pressure. And that's why 0 Kelvin has to be the correct answer for this guy. Once you understand the last question, you got this guy left. Because in question number 7, they're asking exactly what I just described to you. And all motion stops at 0 degrees Kelvin. In this question, you need to understand that solute is like if potassium chloride goes into water, KCl in water. The solute is the potassium chloride. The solvent, if we have potassium chloride in water, is water. So whatever is dissolved in something else is going to be the solute, and the solvent is the stuff that it's getting dissolved in. Now, when we look up here at ethanol to try to figure out why is ethanol the correct dude, and ethanol is, of course, letter A. Okay, why is ethanol the right guy? Because it is infinitely soluble. All of these others are only soluble to a degree. What does that mean? Water and ethanol can be together in any combination. One will be a solute and the other will be a solvent. What determines that is that the solute, let's put that in a different color, solute is the stuff that we have less of. So the solute we have less of. If we're pouring potassium chloride into water, normally that is going to wind up being the solute, and only a certain amount of that will dissolve. That's what solubilities are all about, which is what they're talking about in this column right here. So with our friend ethanol, which is right here, ethanol, dude, will get poured into water, or water can get poured into ethanol. It really doesn't matter. Whichever one we have more of will be the guy that is going to be the solvent. And the one we have less of is the guy that will be the solute. By understanding question 8, you know the question or the answer to this guy. Solute is going to be the crystals. Okay? So the coffee is the solute, the solvent, the water, is the stuff that there's more of. So this process produces a coffee solution. The original crystals, these guys are classified as, there you have it, letter C. And so that one's pretty easy with the explanation from question number 8. Okay, on this problem, most of my students understand this pretty well when we talk about pouring salt into water. You pour salt into water and it dissolves. Okay? The reason that D is the correct answer right here is it dissolves as particles are pulled away from the crystal lattice by the liquid molecules. Okay? The liquid. So there's a wonderful little model that I show my classes that shows water molecules surrounding first sodium atoms and then chloride atoms that are in a salt lattice, which means we have a lattice that's made of first sodium, then a chloride, then a sodium, then a chloride, then a sodium, then a chloride in that order, in all directions. Okay? Left to right, right to left, top to bottom, and all of those little guys come across or come out as water molecules surround them and reduce the attractive forces between the positive and negative charged ions, positive being the sodium and negative being the chlorides. That's it. I hope you find this helpful.